the area of that rectangle. We all know the area of this rectangle is base times your height, so 2 times 18, so that would be 36. And if it was inches, it'd be inches squared, feet squared, whatever. Okay? What a geometric mean is giving us is if we made this into a perfect square, what would these lengths be that would give us this same exact area? All right, Armando. Good. These would both have to be a 6. And we'll show this algebraically here, what this little setup here gives you, and how these end up being the same. 6 times 6 would give you this 36. Okay? So here's what this is now and how we're going to set up this proportion to show that. And then we'll do the same thing with our area using these numbers. Okay? So a geometric mean is a proportion. That's what we left off with. We were doing a bunch of those for the 2 or 3 weeks before break, in which the means, and we'll define what that means here in a minute, are equal to each other. It's very common in geometry, very common in business, and compounding interest, things like that. But here is the proportion that you're going to set up. So the word extreme, if we are given an extreme, those are kind of your smallest and your biggest. So if we look at example number 1, when it says find the geometric mean between the numbers 4 and 8, since this is your first number and this is your last number, since we want to be in between those are what we would label as our extremes, the smallest and the largest numbers. So if we go to set up this proportion right now, the smallest number you're going to put right here, this is what we would call our smallest extreme. That's going to be a 4. And then your largest number, so the biggest extreme value within this set, is going to be the 18. What you are looking for, I'm telling you to find the mean. That's what we don't know. So that's the whole idea behind algebra and variables. Since we don't know that, that's going to be your variable. Well, notice how these are both the mean. So both of these are your x's. That's what we are trying to find. All right, so whatever the extremes are, the smallest value, the largest value, and then the mean is going to be the same. That's what we're looking for. You then have this proportion. This is what we've been working with for the previous month now. You're going to cross multiply, so that we should know. The 4 and the 18 would get multiplied together to give you, what does that give you? 72. And then the x's multiplied together, x times x would give you an x squared. All right. Then we need to solve this. So we've done this periodically throughout the course of the year. The way we get rid of squares, the opposite of a square is a square root. So to solve that and get the x by itself and get rid of that squared, you would do a square root. That means we need to do the square root of the other side. Whenever we did that, we would have talked about how we have a both positive and a negative solution to this. In this instance, and again, I always kind of show that we don't really want the negative because it has to be in between 4 and 18, and the negative value of that will not fall in between a positive 4 and a positive 18. All right, so we're just going to get that positive solution. Let's simplify this guy a little bit. A lot of review here coming back. All right, 72. I won't even ask. We'll talk about it. The largest perfect square, if you remember, if we're going to simplify this, we want perfect squares that go into 72, would be 36 times 2. If you multiply those guys together, they'll give you a 72. And then the 36 is your perfect square. So this is a 6 and then a root 2. All right. What that is telling us is same thing geometrically. So I'm going to have you draw these first couple out. We won't do this long term. But if I had a length of 4 and 18, and I ask you to find the area in here, the area is just your base times your height. So you're going to multiply those guys together. That has an area of 72. If we made this into a perfect square, though, in order to get that same exact area of 72, these would both need to be 6 root 2s. If I did 6 root 2 times a 6 root 2, let's actually show that because it might be the first time we've done this. So if I took those base multiplied by that height, 6 times 6 is 36. And then a root 2 times a root 2 is a root 4. All right, do we agree root 4 is 2? 2 times 36 would give us the same 72. That's what it would have to be as the perfect square. Okay? All right, so one more with that general formula. So this, we're just setting this up here again, so you're not going to be able to see it. Actually, let me write it again. So the extreme over the mean, this is the proportion that we just want to get down whenever you're asked to find this, is equal to the mean over the extreme. So really, it's just the first part of this proportion, that's the smallest number. And then the very last part of this proportion, that is your biggest number. So the 12 is going to go into this spot. That's the first number. And then the biggest number in this set is the 48. So that goes in the very last spot of that proportion. The mean is what we're looking for. That's what we do not know. So that's why we're going to assign a variable to those positions. That's what we're trying to solve for. And then that's our proportion. All right. So then from there, you're going to crisscross solve these. So the x multiplied by the x is the x squared. Cheated earlier, keyed this guy up. And then the 12 times 48 should give you 576. The way we got rid of that squared is with a square root. So we take the square root of both sides. And then this one actually works out nicely because this is a perfect square. So I promise if you plug that into your calculator, I'll show you just so you don't think I'm lying. Square root of 576 is a nice perfect square of 24. All right. So that would be the geometric mean. Okay. So it's not a typical average. You're not just adding those up, dividing it by A2. Okay. But that's how we can set that up when we're talking about a geometric mean. All right. Now here, we're certainly going to use that still, but here's a big part of what we're going to do today. It's why I don't want to give you homework. I don't want to overwhelm anybody this first day because these are kind of weird. So it says an altitude to a hypotenuse. What that is alluding to, let's say I give you this big triangle here. So you don't necessarily need to write on yours. But remember how we talked about an altitude? So if I then drew an altitude, we always had 3 of them, but I want to draw it to the hypotenuse of the big triangle. This is the hypotenuse here because here's the right angle in the big triangle. This is the side opposite of it. So if I draw in an altitude just extends from this vertex and creates a 90-degree angle with the opposite side. That's what this is alluding to. That is an altitude that is drawn into the hypotenuse of a right triangle. Okay? Well, when I do that, notice what happens when we do that. We create 2 more triangles. We create this yellow smaller triangle as well as this blue smaller triangle. So don't we really have 3 different triangles there? The big one that we started with, and then the smaller yellow and the blue. Okay? So what I want you to do is sketch in all 3 of these and then kind of see how they are all similar. So the first one we're going to sketch in, I just like the orientation of this yellow one first. I'm going to draw that one in first underneath triangle number 1. So let's do that. So if we drew that in, it should look, that's the only one we don't have to rotate. That's kind of why I like that one. This is your 90-degree angle. It's in the bottom right-hand corner. And then label it with the correct variables. So this was X, this was H, and that was B. So the yellow triangle, all of those sides are labeled nicely. X, H, and B. Okay, what I want you to do next is we're going to draw this blue triangle now. So look at the blue triangle, but draw it in a way. Last year you would have done rotations. Okay, they would have made you rotate triangles 90 degrees, reflect them, all that fun stuff. You're going to take this blue triangle. We're going to draw this triangle here, but draw it with the same shape and orientation as this one has. So understand then, if this is your 90-degree angle, if I'm going to draw it like this, it should be a little bit smaller. So let's draw it a little bit smaller. But I want it to look like this yellow one as well. So this is my 90-degree angle. Do we agree that this blue one basically got rotated 90 degrees in the counterclockwise direction? So this side here would be the Y, right? So this side right here, this y is now right here. The hypotenuse is opposite of the right angle. That's A. So here's my right angle. This has to be A. And then H is the long leg. So this has to be the H right there. All right. So we have the yellow one, we have the blue one. And then the last one we're going to want to draw, we want to draw it in so they look all the same, is the big overall triangle. And this is probably the trickiest one. I can try to do this. I tried it earlier. It worked somewhat well. No, because I had to rotate it. Never mind. But we're going to draw that in the same way. So draw this in. This is going to be the biggest one. So let's make it the biggest one. Just to the to our eye. But now be really, really careful. So here is the right angle. So I'm drawing in this one right here. Here is the right angle. Isn't the hypotenuse of the right angle letter C? This full side C. So this here is your hypotenuse. That's got to be C. All right, here is the short leg. So look at the big overall triangle. Which of those letters, the A or the B, is the short leg? Let me look at that. Sarah? Good. It has to be A. So this has to be A. And then the longer leg here is the B. That has to be this guy. All right. The reason we want to be able to do this is because as we start looking for lengths, this is going to be one of our options to now kind of understand that these are all similar triangles. So you don't necessarily need to write this, but I could say that like B is to A, and I did this hypotenuse to this hypotenuse, as H is to Y. But when they're all written like this, it's really hard to see all these similar triangles in each other. If we can separate those into three separate, then it makes things a little bit easier. Okay. That's what we're going to do in this next problem. So one more time, go to example number 1 on that next page. And now I'm going to give you some values. So now we're going to do a little algebra with this. So let's say I wanted you to find this value of x right here. One of the options we have to do that is to draw our 3 similar triangles. So for one more time, let's draw these triangles in. So the first one I'm going to draw again is, I just like the way this one is oriented. I'm going to draw in the one that I just highlighted in blue. Okay. So the triangle number 1, I'm going to draw in just like this blue one looks. All right. So this is 15. This is x. We don't know this length right here. Okay. And that's okay. At least hopefully it's okay. But that's the blue one. All right. Then do your best. Let's sketch in the yellow one, but draw it in a way that the right angle is again the bottom right-hand corner of that triangle. Okay, so basically this yellow one, we would need to take this vertex and he would need to fall to the ground here. It's going to be a little smaller, so I'm going to make it a little smaller. Here's my right angle. This right here, this 5 would now have to be this length here. And then this x right here would now have to be this base. And then opposite of the right angle in the yellow triangle, notice how we don't know the opposite of the right angle. We don't know our hypotenuse here, so we don't know that. Okay, so that will leave blank. All right, and then the last one, the trickiest one to draw in the big overall one. So now we're going to draw in, make this really dark. We're going to draw in the overall triangle that we would have started with before we drew that altitude in. But again, do it in a way that the right angle is oriented in the same position as the previous 2. All right, so then now be careful. Here's your right angle. Opposite of this right angle is the hypotenuse. So what is the overall length of our big triangle's hypotenuse here? What would that have to be? Yeah, Good. That would have to be 20. So here's the right angle. Opposite of the hypotenuse is going to be a 20. All right. If we then look at those legs, we don't know this leg, nor do we know this leg. So we're not going to be able to label those. All right. So now here's what you're going to do. See if you remember this from break. Set up a proportion that would allow you to solve for x. And to do that, we need two sets of corresponding sides. Okay, so look at the three triangles. You want to use two of those triangles where we have two complete sets of corresponding sides. And then set up that proportion. All right. The only two we could use would be these first two here. Because if we come down here, we only know one of those sides. So we don't know enough information here. But if we look at these two, don't we know the right side of this triangle and the right side of this triangle? So I'm going to write that as x is to 5. So I just went right side to right side. And I went the one on top compared to the one on the bottom is equal to, and then I'm going to do the top bottom to the one on the bottom here's bottom. So 15 is to x. Okay, that's kind of what we left with for break. Okay, do we understand where that comes from? All right, then crisscross, multiply. So you're going to get x squared is equal to 15 times 5, which is 75. Take the square root of both of those. We'll be doing that a lot here. We get the square root of 75. We do want to review and remember how to simplify this. This should be a nice one. We want a perfect square that goes into 75. That would be 25, and it would go into it 3 times. So that length must be 5 root 3. Okay? And then we could figure out that that's how long this segment is right here, that altitude is. Now, you can see here, this would be kind of a pain in the butt, all right, to draw these 3 out each time and then kind of figure out what matches up, where our similar sides are, and then set up our equation, do our proportion. That would take some time, all right? But there are some shortcuts to these. So this first shortcut, and when we do it, we better get this exact same answer that we just got. We better get 5 root 3, okay? So it says the shortcut, it says the length of the altitude to the hypotenuse of the right triangle. That's what we're looking for right here. We were looking for the altitude drawn into the hypotenuse. Is the, and then we're going to start using these words from the front page, is the geometric mean of the lengths of the segments of your hypotenuse. So here's what this means. Write in, did I give you the same one here? No. So write in the same thing that we had on the front page, that same proportion, the extreme to the mean, and then the mean compared to the extreme. All right, and then let's read through this one more time really carefully. The length of the altitude to the hypotenuse of a right triangle is the geometric mean. So notice where we have the word mean. That is the length of our hypotenuse. So the length of our hypotenuse right now, if we were to set this up with this shortcut, that's going to be your x. Okay, so I'm going to erase this. X is what we were looking for. That is the altitude. So we're going to put the x's right there. All right, and what it is equal to, so I'll do this because this will be the extremes now, is the lengths of the segments of your hypotenuse. So this is our hypotenuse right here. Notice what those two lengths were. They were 15 and they were 5. So if I went ahead and put those two values into these positions, 15 and 5, notice how it's the same. Well, let's solve it. When we crisscross and solve, won't we get 75 here? and the x times the x is going to give you x squared, doesn't that give us the exact same initial equation that we got up here? All right, but much quicker. We don't have to sketch out 3 triangles. We can do that very quickly. Okay. So when we now do this one, you have your 2 options. We could draw out all 3 triangles, this triangle, the small triangle, and the big triangle. Or we can now use this little shortcut, which is sort of what we would prefer. All right, so set up this proportion. And the key to this is this idea: the length of the altitude is the mean. This is your altitude right here. The altitude is your mean. So now we actually know what this value is. So the word mean is your altitude. So you are going to put 6 into those positions. So 6 and then 6. The altitude is the mean in our proportion. And then what it is equivalent to, or what they're compared to, is the length of the segments of your hypotenuse. So here are the 2 lengths of our segments of the hypotenuse. One of them is 4. The other length of the hypotenuse here is the x. So you need to put x into one of these positions. You need to put 4 into the other. Doesn't matter which one you put in. All right. We don't really know which one is bigger and smaller anyway. So I'll put the x here and then the 4 there. And then we have our proportion that we can solve. All right. So we're going to crisscross. This one's a nice one. So this is 4x. 6 times 6 is going to be 36. We don't have to worry about square roots in this case. Go ahead and divide by 4, and then we can find x to be a 9. Okay. Okay. Next one. And again, we'll do this a handful of times, and eventually, as you know all the shortcuts, we can skip this. But this is now a new little rule here. Notice how I'm not looking for this altitude anymore. Okay, so that's why this is going to be a little bit different rule. So what I want you to do first is same thing that we did in those first couple. Let's draw these 3 triangles out. All right, let's draw them all out. So again, I'm going to draw this one first. Oops. So the first one I'm going to draw is this guy. I think this is the one that is easiest to see, easiest to draw. So triangle number 1, we'll draw in what I have highlighted in blue. And then that means my right angle is here. In that blue triangle, I know the bottom is 9, and I know the hypotenuse is x. I don't know what this length is right here. If we look at the diagram you were given, we don't know what that is, so we don't have anything to put here. All right. The next one I'm going to draw in is this guy rotated so that it looks like this. So I'm going to take that yellow triangle. It should be a little smaller. Here's my 90-degree angle. We don't know the hypotenuse. So if this is this yellow triangle, we don't know the hypotenuse. So we're not going to know this length. We do know the short leg here is going to be a 3. But we also do not know this guy. We only need one of those. All right, but that's our second one. And then the third one is the big overall triangle. So the third one is this big guy that we started with before we drew the altitude in. So that's, again, the trickiest one to draw in. We want the right angle to be the bottom left-hand corner. All right, then here's this right angle. So in the big black triangle right now, opposite of the right angle is its hypotenuse. That whole length is 12. The 3 and the 9 together is the hypotenuse. So here's our right angle. Opposite of the right angle is a 12. If we look at the 2 remaining sides, here's the small side, here's the longer side. If we look at our new one down here, short side, longer side, we know the longer side is the x. All right, so now we have all 3. Pick out the 2 triangles that you are looking at that have corresponding sides and set up a proportion with those. And which triangles, in terms of the ones we drew off to the side here, which triangles do we need to use? 1 and 2, 2 and 3, 1 and 3. Which ones will allow us to get a complete set? Good, 1 and 3. So 1 and 3 are the two that we can get two complete sets. There's not enough information in number 2, so that didn't do us any good. But if we look at 1 and 3, did you set it up, Jason? Had you set it up yet? Okay. So Jason was the one who said it's definitely 1 and 3. So now let's just compare our corresponding parts. Here's the hypotenuse in number 1. Here is the hypotenuse in number 3. So we'll put x over 12. So hypotenuse compared to the hypotenuse. And then the base of triangle number 1 will compare to the base of triangle number 2. All right, so 9 over the x. And that's how we can set up a proportion. We can then go ahead and solve that. X times the x is the x squared. So we're back to having to use some square roots. 12 times 9 is going to be 108. Take the square root of both sides. All right. A little trickier. And again, we'll give you this today. 36 and 3 would give us that 108. And 36 is the perfect square of 6. So this would be our answer there. But again, kind of a pain in the butt to have to draw all of these out. All right, to see sort of what our similar triangles are and what the corresponding sides are. Okay. So not something we want to do long term. So here's the shortcut in this case. So now understand, we don't have this altitude. So let's now do this with our shortcut. So up here underneath, or somewhere where you have some room, write this same little proportion that we started the class with. And then we'll read through the shortcuts. And then we'll do that same problem and we'll get this and it should be quicker. All right, so it says the altitude to the hypotenuse of a triangle separates the hypotenuse so that, and then here comes the important part, the length of each leg is the geometric mean. Okay, so the length of each leg is the geometric mean. So come up to this right triangle, this big black triangle. Let's redefine some terms. If this is your hypotenuse, which it is, then these are our two legs. So we'll call this leg 1. And this is leg 2. All right, those are our legs. The one that we were looking for is leg 2. So what you just read, what I just highlighted is the length of each leg is the mean. So in the position where I have the word mean, we are going to insert the leg. And in this case, the leg was your x. All right, that's what we were looking for. So I'm going to erase this, and what we know in this triangle, those are x's. All right. And then if we continue to read, it says to the length of the adjacent hypotenuse segment, and then the length of the hypotenuse itself. So here's what this now means. Let me clean this up just a little bit. So here's the side we are looking for. Adjacent means right next to. So when it says the adjacent hypotenuse segment, this is the adjacent hypotenuse segment. So I'm going to put 9 here. And then the second part of that is and the length of the overall hypotenuse. So if we then compare that to the length of this overall hypotenuse, isn't the length of the overall hypotenuse a 12? And when we now go to solve this, you're going to crisscross 108 equals x squared. Isn't that the same thing that we got over here? If we solve that, you're going to get the exact same answer. Okay? So that's our shortcut. So last one. Come down here now. Let's see if we can kind of understand what this is saying. So what we want to figure out first, do this for me. Find x. See if we can do that. That's the previous one. All right. We know this is a 6. We don't want to have to draw all 3 of these out, hopefully. So that rule is when we are actually talking about the altitude is the mean. All right. In this case, we know what that is. It's 6. So in those positions, we would be putting a 6. All right. And then notice how when it intersects the hypotenuse right here, it creates these two sides. This side here and this side here. Those are then the extremes. So one of them is x, and then one of them is 9. Right, the two segments that creates. That's our setup. This is a nice one. When we crisscross and solve this, we would get 9x equals 36. Divide, and we now know that the x is a 4. Okay, so that's our first one. That's the one that we did earlier. Here's the new shortcut. So now let's do the y. All right, so if I wanted y, this is the leg of our right triangle. So let's write this again. And the key with all these, understanding that one of these lengths is always the mean. And the other rule is this leg right here is your mean. So that is now a y. So you're going to put a y here in here. And then what your extremes are going to be, what it's proportional to is the adjacent length. So this adjacent length right here is 4. So one of them is going to be a 4. Compared to the entire hypotenuse length right here. So that entire length we can now say is what? Mo? 13. The 4 and the 9 together means that entire length is 13. Okay, so that's what we crisscross solve. All right, 52 is equal to y squared. And then y would be root 52. That does simplify. I want to get to this last one. It's 4 and 13, so this should be 2 root 13. Okay, so that's our y. So we know this is 2 root 13. And then one more. All right, so let me clean this up. Last one. We want to solve for z. Z is another leg. So again, let's write this out. Extreme over the mean is equal to the mean over your extreme. The leg is always a mean. So notice how that is now a z. So in those positions, you're going to put a z. And then what we compare it to is the adjacent side. So this side right here is the one that's right next to it on the hypotenuse. So you're going to put 9 into one of those positions. Compared to the entire hypotenuse length. And we now know, what did we say x was? X was a 4. So this whole hypotenuse would have had a length of 13. All right, and then that's our proportion. All right, crisscross. Ooh, what is that? 9 times 13. 7 117. That's good because you can't do much with the 117 here in a minute when we do our square root. So z squared is 117. Take the square root of both sides. And root 117, can't do anything with it. So then that's just your answer. Okay. All right, kind of confusing stuff. That's why I'm not giving you homework tonight. We'll kind of do some more, and then I'll give you a little bit of time to kind of work on this in class because it's sort of weird. It's not my favorite section. So bring this tomorrow, or not this tomorrow, but we'll go over this again tomorrow, and then I'll give you some homework for you to practice tomorrow when we've had a couple of days of looking at it. All right. Plus, nobody wants homework the first day back from spring break.